Welcome to the second video on linear equations. We're going to do two word problems. C. Hicks owns a local ice cream parlor. His single scoop cone sells for 89 cents, and the giant earthquake of 8 scoops sells for $6.07. The cost of ice cream varies linearly. And so when something varies linearly, that means that we're going to have a straight line. Okay, so define the variables, write the ordered pairs, determine a valid domain for this function. So um, I'm going to make the variables x and y, but sometimes you may want to make them different letters. So, for example, um, S for scoops and C for cost might be another way to do that. So I have to determine which variable is going to be the independent variable, which I will make x. So independent means it is the thing we can choose. Independent has a D in it, Mr. Mead. So I can do that. And then dependent, I'm really struggling with the whole spelling thing at the moment. So the independent variable x and the dependent variable y. So the independent variable is the thing that we have control over in terms of what our choice would be. And in this case, that would be the number of scoops. Y, the dependent variable, is going to be the cost, which in this case is going to be dollars. So the points in this problem are 1 scoop and 89 cents. And then it appears that I have an 8 scoop earthquake for $6.07. So those are the 2 points I have. The valid domain for this problem is going to be the integers. Actually, the positive integers. Because I can't have a negative value of scoops, um, and I can't have a fractional scoop. So the positive integers are going to be the domain for this problem, which we can also call the natural numbers, or n. Find the slope and write the particular equation expressing the cost in terms of the number of scoops. So I'm going to find the slope, so $6.07 minus 89 cents, divided by 8 scoops minus 1 scoop. So 607 minus 89 is $5.18. And I'm going to take that and divide it by 7. And that ends up being a 74-cent slope. Now remember, slope is not just in terms of 1 unit. So this is the cost in dollars per scoop that I have. And we're going to write the particular equation. Uh, it's probably not easiest to find the slope intercept yet. We will probably want to write point slope form. So y minus 0.89 equals 0.74 times x minus 1. I'm just taking one of the points and the slope and substituting it in. Now, if I want to find slope intercept, I can. And that may actually be easier in this problem. So if I distribute, I'll end up with y minus 0.89 equals 0.74x minus 0.74, and then add the 0.89 over. So I could end up with the equation y equals 0.74x plus 0.15, and that gives me a slope and a y-intercept. So the rest of this is just working with this equation, and I think this equation is actually the easiest to work with rather than using a point slope in this particular format. So what's the price of a cone with 4 scoops? So what I would end up doing is I would take uh, y equals 0.74 times 4 plus 0.15. And after I do that, I'll end up with an answer of 296 plus 0.15, so I get $3.11. And then if I did the same thing with 12 scoops, I end up with $9.03. So that would be the price there. This is kind of a working backwards problem. So 2235 equals 0.74x plus 0.15 because the monetary amount, the dollars, would actually go in for y in this case into the original equation. So now I subtract 15 cents and I get 2220 equals 0.74x. And then I divide by 0.74. I end up figuring out that that is 30 scoops when I divide by the slope. What is the cost intercept? So that's the same thing as the y-intercept in this problem. That is 0.15, so it's 15 cents. And that real world meaning would be something like the cost of the cone or something else that is being put into this particular problem that is in addition to the scoops. So something that before you get any ice cream, you would have to pay 15 cents. The cost per scoop was 74 cents. And what part of the equation tells you that? That was the slope. So now we're going to graph the function. And when I graph the function, remember that I only have integers in my domain. So since I only have an integer domain, what I'm going to do is I'm going to label things properly. These are scoops, and this is cost in dollars. And I'm going to make this really simple. Like I'm going to put 0.15, 0.89, and then I had a $6.07 thing up here. And I could actually add by 74 every time, but I'm not going to spend the time doing that. So 1 comma 89 and 8 comma 607. And that's kind of what the graph looks like. And I could draw a line, but I want to really emphasize in this chapter the fact that we have an integer domain. So I'm only going to put integer values of x on this line. So I'm only going to put the points that represent the actual number of scoops I can have, because I cannot have some sort of fractional number of scoops in this problem. Okay, Mr. Mead is shooting baskets before school on a Friday. He's keeping track of how many shots he made this week. 15 minutes into the Friday workout, he had 560 makes. 35 minutes into the Friday workout, he had 640 makes. While makes aren't necessarily linear with respect to time, we're going to assume so just for the interest of um, just making the problem easier. And they're relatively linear, even though some people may be a hot or cold basketball player, like they make all their shots in a row and then miss a bunch in a row or something. We're just going to assume it's linear. One thing that you have to keep in mind, he's keeping track of how many shots he made this week. So these numbers do not represent the numbers in this particular workout. They represent the numbers overall in the week. So we're going to determine the variables. X is going to equal time in minutes. And this time only represents the time that he's done on Friday. Y represents the makes, but these makes represent the makes all week. So that's something that we have to keep in mind. The valid domain, minutes are continuous. So the domain is going to actually be the real numbers, but it's going to be positive. So we have to have positive real numbers. Find the slope and write the particular equation expressing makes in terms of minutes. And so let's write an equation. So if I'm going to do that, then I need to take a look at um, the 2 points that I have. Oh, I forgot to write the ordered pairs. So the ordered pairs in this problem are 15, 560, and 35, 640. So if I do the slope equation, I end up with 80 divided by 20. So that means my slope is 4. And then I have to figure out my y-intercept. So I can figure out my y-intercept. Actually, I don't have to figure out my y-intercept. I can just write this as a point slope equation. So y minus 640 equals 4 times x minus 35. And then when I solve this, I can get a y-intercept. So I distribute, I get y minus 640 equals 4x minus 140, and add 640 over, I get y equals 4x plus 500. I know that's something that shows up later, but kind of flows from what we're doing in part B. So that means my y-intercept is 500, and we'll talk about that in a minute. So in part B, it asks for a particular equation. I do not have to write the slope-intercept form unless it tells me to. I can write the form in point slope or standard or whatever's easiest to do. How many makes would Mr. Mead have after 52 minutes? So I can just substitute in 52 to my equation, and I will get the correct answer. So when I substitute in 52, I have 708 makes. Mr. Mead wanted to have 700 makes. This is substituting 700 in for y. So then I solve this and I get x equals 50 minutes. So that means that Mr. Mead only has to shoot for 50 minutes in the morning to accomplish the goal. Convert this equation to slope-intercept form. We already did that, so y equals 4x plus 500. Is it helpful? Yes, it is helpful. Why is it helpful? To get the y-intercept. And we already got that. Oh, hey, look, letter F asks for the makes intercept, 500 makes, which I could write as an ordered pair 0, comma 500. What is the real world meaning? That means that he entered Friday with 500 makes already. So that means that entering Friday, he had 500 makes for the week. Convert this equation to standard form. This is not hard because everything is already in integer format. So all I have to do is subtract 4x from both sides just to get more practice, just getting things in that sort of order. And then graphing the function. Now, graphing the function, we are actually going to draw this as a line because it is continuous, but it's technically not continuous, just the model is continuous um, in terms of time. But like actually what happens is if you think about it, he has a certain amount of makes for a period of time and then he makes one. Then he has a certain amount of makes for a period of time and then he makes one. And let's say he misses a couple, then he makes another one. Then he makes one, then he makes one. It's actually going to look like stairs, so to speak. If you think about it in terms of like this being the x-axis of time and this being the y-axis of makes actually have to be whole numbers and time is continuous. But that's a little bit complicated for right now. So that's what the graph would actually look like. But when we graph this, we're going to start at 500 and then we can go up, let's say, um, I'm going to count by 20s over here and so on. And then that's makes. So 580, 600, 20, 40, 60, 80. And then I need one more to get to 700. And then let's go up by fives down here, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So then I know that 50 comma 700 is on the graph. I know that 0, comma 500 is on the graph, and then I can graph that as a line, even though technically it would look a whole lot more like this.